Salutations, fellow chemists. Have you ever wondered why does ice float on water? It's actually something that's quite weird. We know that solids are closely packed, and usually this means they're a lot denser than liquids. So that means a solid version of a liquid substance should be more dense. However, that's not the case for ice and water. So let's explain, why is ice less dense than water? This is a classic 3-mark question. Before we get there though, I want you to look at my 2 diagrams here at the bottom. So let's start with water over here. You can see how closely packed these are here, and we can imagine, if I quickly pop these on here, lone pairs on here, giving us nice hydrogen bonds like so. We might not have as many hydrogen bonds as we want over here, but I'm just showing you a few of these like so. However, in ice, they arrange themselves in hexagonal units, and these units here, you can see the lone pairs giving you our hydrogen bonds like so. And this arrangement of hydrogen bonds makes the water very, very stable. However, it does leave lots of open gaps in between, which is not ideal. So when it comes to answering this question, let's swap pens for the green one and green one here. So why is ice less dense than water then? In terms of answering this, looking at these two structures, what you can say is, for the first point, ice forms an open lattice structure. And lattice just means regular repeating structure. And what that means is there are lots of gaps. It's not ideal. Okay, so what we can say is this keeps the water molecules. So this keeps the H2O molecules further apart. Molecules further apart in our ice, further apart than in the liquid water, than in the liquid form. So than in liquid water. And the last thing, hopefully I've got some space to squeeze this into the last bit. When it melts, when the ice melts, what happens is we can see some of the hydrogen bonds over here are overcome. So when it melts, some H bonds, make sure you write fully hydrogen bonds, I'm just writing H bonds for space, are overcome. And that brings the H2O molecules a lot closer, and that's why we end up with a more dense version in the liquid. So this is the liquid than in the solid, which is very weird. So H2O molecules closer. So hopefully that makes sense for you, and you understand why ice is weird and why ice is oddly less dense than its liquid version. Make sure you check out the Chemistry My Resources as well whilst you're here, and I'll see you in the next video. Drop a comment and we'll see you soon.